Hello, this video is about sequential circuits. We have two types of logic circuits, one combinational and second one is sequential. Combinational circuits are also called non-regenerative, so they do not store previous events, and output is a function of only current inputs, and combinational circuits do not produce an output dependent upon previous inputs. On the other hand, sequential circuits are also called regenerative. The output is determined by the current inputs as well as the previously applied input variables. We can say that the sequential circuits has a simple memory function to store the previously applied inputs. We have three types of sequential circuits: bistable, monostable, and astable. Bistable sequential circuits have two stable states, for example, flip-flops, registers, and memories, which we will deal with for the next weeks. Second type is monostable. They have only one stable state, so the output will eventually return to the stable state if the circuit is experiencing an external perturbation. And astable circuits do not have a stable state. Thus, output oscillates without settling into a stable operating point. Here we see a monostable circuit example. If we do not apply anything at the input and it is constant 0, and let's assume the initial output is 0, 2, then this point will be 1, V1 will be 1, and output will be 0. So it is one stable point, output is 0. Assume we have applied a trigger input. When this point is 1 and this point is 0, this point, the output of NOR gate, will go to 0. However, other side of this capacitance is connected to supply, so this capacitance will be charged through this supply voltage. You can see the charging up on this plot. So for a while that V1 point will be 0, but it will be increasing due to the capacitance here. Once it is filled, this input will be 1 and output will be 0 again. So it will eventually go back to its stable state. You know ring oscillator as a astable circuit example. This doesn't have a stable operating point. Only when all the inputs and outputs are VTH and the inverters are identical, then this ring oscillator structure has an astable operating point. However, with a small perturbation, it will change its state and it will start oscillating. Here we have a very simple bistable circuit, two inverters cascaded in this form. So input of the first inverter is equal to the output of the second inverter, and output of the first inverter is equal to the input of the second inverter. This circuit has two stable operating points. When this point is 1, output of the inverter will be 0. When input of this inverter is 0, output is 1. Or when input of this inverter is 0, output will be 1, this point will be 1, and output of second inverter will be 0. If the circuit starts operating at one of these two stable points, it will preserve its state. But if we apply a sufficiently large voltage perturbation, the state will change, and eventually the state will go from one to another operating point. The potential energy is at its minimum at the two of these three operating points, since the voltage gains of both inverters are equal to 0. By contrast, the energy reaches a maximum at the operating point at which the voltage gains of both inverters are maximum. Thus, the circuit has two stable operating points corresponding to two energy minima and one unstable operating point corresponding to the potential energy maximum. And this unstable point is where V in and V out are equal to VTH. Here you see the transistor level of the bistable circuit. We have 4 transistors, and at the unstable operating point of this circuit, all 4 transistors are in saturation, resulting in a maximum loop gain for the circuit. If the initial operating condition is set at this point, VTH, any small perturbation will cause significant changes in the operating modes of the transistors. Thus, we expect the output voltages of the two inverters to diverge and eventually settle at VOH and VOL. This transition can as well be shown on a phase plane representation. Here we can show our operating points, this point, and here when both of the outputs are VTH. And we need to show the direction of this unstable point. So with any perturbation, the output of VO1 will go to VOH, or output of the second inverter will go to VOH.